In this video, we'll take a look at comparing the two frameworks and comment on their different designs. We'll go over the benefits of Keras and the separate benefits of Gluon. So Keras, as we saw from implementing both dense neural network and logistic regression in videos so far, has a very high-level API and a large number of available models. We've really only used it with TensorFlow, but another thing it has is multiple backend support. You can actually use Keras with TensorFlow, CNTK from Microsoft, and there's even upcoming MXNet support. So it's a great benefit of portability. If you code your model to Keras, you'll actually find that you can run it in a lot of locations, and you'll actually find a relatively large set of community and models online. You will definitely find Stack Overflow comments, and you'll be able to make a lot of progress by searching and sorting and sharing with other programmers. Gluon actually has a lot of benefits too. There's a very high-level API. You can actually build a network in a relatively simple fashion, especially compared to what you saw with the code with TensorFlow or MXNet. Gluon actually lets you build a neural network in a pretty straightforward fashion at a really programmer-friendly level. There's actually a large number of available models, particularly inside Gluon's repository on GitHub. So you can copy and paste those models, work with them, refine them, and you never really have to start from scratch. Another nice thing is there's a lot of pre-trained models in the Gluon library. So this isn't just a model that you can run. This is a model that the Gluon developers have actually run on a large set of training data, evaluated, refined, and fed back. And then you can do a thing called transfer learning. You can actually take a model that's pre-trained and then add in a little bit more data that's your own actual data in order to finish and fine-tune your model. It's got imperative execution. So Keras and TensorFlow has a declarative style. It runs and it optimizes, but you can't really see inside or poke at it. Whereas with Gluon, because you have to write your own training loop, which is a little bit of a downside in that it's more code, you can actually take a look inside and debug and step through your model a little bit better. Gluon also has generally faster performance. MXNet is actually pretty fast, and it has a tiny performance edge over Keras and TensorFlow at this time. But the reality of it is all of these frameworks are in active development, so the performance edge moves back and forth release by release, particularly when you're talking about implementations with GPUs, because NVIDIA updates the cuDNN and CUDA libraries on a regular basis, and it's a very horse race effective, which is the fastest library at any one time. Gluon does have a few drawbacks. There's more code required. You can see from all the samples we worked on that every time we ran it, we actually ended up typing a whole lot more to get the model to work. It's MXNet only, whereas Keras actually is a little bit more flexible in that it supports multiple different backends. And Gluon is substantially newer than Keras and TensorFlow, which means it's less popular. You simply won't find as much code on Stack Overflow or Googling around. Alright, in the next video, we're actually going to start up a mini project. CIFAR classification of images using multiple different deep learning models.